Dear students, hope you are fine and are safely inside your homes amidst this corona scare. We will resume our studies through this medium for next a few days until things are put in proper order. In this video tutorial, we will study about Turing machines. So what are the Turing machines? Let's study them physically first of all. A Turing machine has a tape as its first component. The tape is infinite from both the sides. This is indicated by these symbols. So it goes on this side also and goes on this side infinitely. This tape is divided into cells, and each cell can contain a single symbol. We will learn in detail what symbols are. Every cell can contain only one symbol, and usually these symbols are used as sentinels of boundaries of this string. Apart from this tape, we have a read-write head. Note it down that this time we have a head which can read as well as write. Earlier, in case of finite state automata, we had the head which could read only. So specialization of this head is that it can read information from the location, from a particular location, and write also, means this information is quite probable to be changed after the transition. Secondly, this read-write head has option to move in either direction. It can move towards right or towards left also. Earlier, in case of FSA, this head moved in one direction only, that is in the forward one. Now it can move in left and right, both directions. The third component is the finite control. So this system controls the switching of states. Transition of states between, for example, it switches from Q1 to Q2, then Q2 to Q1, etc. So this is the physical existence of a Turing machine. Now let's study it analytically. Analytically speaking, Turing machine M can be defined as a 7-tuple. First of all, you have capital Q. As in case of finite state automata, it is the finite and non-empty set of states. These finite and non-empty adjectives have a special significance. So Q, as usual, is a set of states, and these states are usually indicated by small q's, Q1, Q2, Q3, etc. Let's move on to the second component of the Turing machine. It is sigma. Again, there's nothing new in it. Sigma is a finite and non-empty set of input symbols. These symbols in this case are A1, A2, A3, A4, etc. So these symbols are also in the form of a set. As the third component, we have tau. This is a Greek letter tau, capital tau. It also is a finite and non-empty set of symbols, but these symbols are known as tape symbols. Tape symbols are the symbols which will be used on this tape, and in addition to this tau, this set of tape symbols includes all the symbols of the sigma input symbols set. And in addition to that, it contains a few special symbols. Example of these additional symbols is B. So B is a special symbol which is not part of sigma, but it is contained in tau only. So B is a special symbol belonging to tau. It is used as sentinel to mark the boundaries of the string. In addition to it, we have Q0. Q0 as usual is the initial state. There is one initial state from where the machine will start working. This state obviously belongs to the set of states. In addition to it, we have F capital is a set of final states, as in case of finite state machines, these which belong to this set Q only itself. So therefore F is also a subset of Q. Here one more thing you have to note is that sigma is a subset of tau, means all the symbols of the input set are contained in the set of tape symbols, but a few additional symbols are there, as here in our example we have additional symbol B used in it. And in the last you have delta. Delta here also is a transition function, which is a mapping from qx to q dash yd. Of course it's a transition function, but it has a little difference from the transition function which was used in finite automata. So it is a mapping from qx. Q is a state, x is the input symbol. So it maps into another state, means machine state switches from q to q dash, and after consuming this symbol it generates another symbol y, which will be written on the cell of the tape under the head. And in addition to it there is special symbol D. D is actually either L or R. L means left and R means right. This indicates that after transition your head will move towards which direction, either left or right. So now your machine will work like this. In the beginning it will be in some state, say Q1, and it will read the symbol from tape, and with that combination of input symbol and the state, it will switch into some other state, let us say Q2, and write some other symbol from the set of the tape symbols, and it will in addition to it the head will move either towards right or towards left. Note it that this movement is just for one step only, means it will move one cell to the right or one cell to the left, not more than that. One tool to describe the transition system is transition table. I have a copy of the table. It has various columns. First of all, major column is present state. It's a bit similar to the transition table as in case of finite state automata. We will see the differences also. First column is column of states, in which machine presently is. So it contains it contains all the states Q1, Q2, Q3, Q4, Q5. For example, there are 5 states. As usual, initial state is marked with this arrow and final state is marked with this circle. And on the right hand side we have tape symbols, column of tape symbols. In this case, in this example, we have two input symbols 0 and 1. Here in this example we were having A1, A2, etc. In this example we have these two symbols as input symbol 0 and 1, and an additional symbol B as tape symbol. So here sigma contains 0, 1 and tau contains B, 0 and 1. Right? So look at the first entry. First entry is concerning Q1 state and B symbol. Similarly, second entry is concerned with the Q1 state and 0 input symbol at the tape. This means this is the output when your machine is in the Q1 state and it faces B as the tape symbol. So now let's see what exactly this is. its first part in this entry, the first part is the tape symbol which is to be written on the tape. So after reading B, it will erase it and it replace it with 1, and the rightmost part is the state, so the state in which it will switch to. So from Q1 it will switch to Q2, and in the middle it is written L or R. This obviously means that the head will move to the left. Means if on the tape, suppose it finds B and the machine is in Q1 state, so it will read this symbol, and state is this, so Q1 B combination. So it will remove this B from the tape and will write this symbol, so it will be B will be replaced with 1 and the state will switch to Q2 now. And thirdly, the head will move to one step left, so this head will move to this location. So this means that is the complete meaning of this entry. Similarly, this entry says that if the state is Q1 and the tape symbol is 0, then tape symbol will be replaced by 0 itself, means there will be no change, and state, there will be no change in the state also. Q1 will be Q1, but the head will move to the right. So if it is here, it will move to the right, to the cell on the right. Similarly, you can see the complete description of the table. And one more thing you need to focus is that there are a few columns in which there is no entry. This is quite probable and it's valid also. So this means that if machine is in Q1 state and it faces tape symbol 1, it will do nothing. Machine will halt here. So there is nothing like this that in case of finite automaton, machine had moved on right direction and at the end of the string it stops. But in this case, the head moves in both direction. Even after reaching here, it can move to this direction. So this does not signifies the completion of the string. But such cases, for example, Q1 and 1 combination will mean that machine will halt. Similarly, if machine is in Q3 state and it receives B as the tape symbol, as there is no entry, so machine will halt. So these are the points where your machine can halt. Now let's see how movements of this machine from one point to another point it takes place. To study it, first of all, we need a technical terminology, ID. ID is instantaneous description. It means that exactly at this moment, what is the status of this machine? It is actually depicted by a string alpha q a gamma. If you see it clearly, it is a string in which alpha and gamma are the substrings of tape symbols. A is a single symbol and Q is a state. So this shows the present state, and the string to the left of this is the string which is on the left of this head, and to the right of this head the string is broken into two substrings. First is a single symbol and the rest is a string. So for example, instantaneous description for this machine is, let us suppose this machine is presently in Q1 state. So in this string you insert a Q1 here to the just to the left of the symbol which is directly under the head. So for this instantaneous description will be B, A1, A2, A1, A1 again, and this is the position of head. At this location you will write the state. So Q1 is, let us suppose, the state, and after it you have A2 and then A3, A1, A2, A3 and B. So this string is the instantaneous description. So instantaneous description is the current status of the machine. As your machine moves ahead, it will be describing it will be described by the instantaneous descriptions. So for better understanding, we take an example. Let's take this transition table, which in return describes the Turing machine completely. The set of states is given here. Sigma, second part of the Turing machine, second component of the Turing machine. Sigma contains 0 and 1. Tau is 0, 1 and B. Delta is the table itself. Initial state is Q1. Special symbol is B. And final state, set of final state contains just one final state, that is Q5. Now let's take an example that we want to check what happens if we feed this string to the machine. So we will do that in terms of instantaneous descriptions. So ID at the beginning will be like this. Machine initially will be in the state which is initial state. So Q1 is the initial state, and the symbol, because this is the string fed to it, the first symbol will be under the head, and the rest of the right string will be like this, and this string will be shown boundary with the B. So this is the ID at the initial state. So this is also known as initial ID. As the machine moves, the next move will be indicated by this symbol. So now what will happen? Machine is in the Q1 state and it receives 0, right? So we will go Q1 state 0 symbol, we will refer this move 0 RQ, means the symbol will be at present the machine is like this, head is here, this symbol will be removed, and instead of it symbol written will be 0, right? By chance this is the same, so 0 will be removed and 0 will be written again, so therefore there will be no change in this. Now what next? After replacing this, the state will be changed to Q1. By chance this is Q1 itself, so state will be Q1 as such, but the head will move to the right. So after this transition, your head will move to this cell. So now for this, state will be Q1. So for this, instantaneous ID will be written as the symbol under the head is 0. So to the left of it, write the state Q1, and the left of it will be string, left of it will be symbol 0, and this will be the instantaneous ID at the next moment. So now what next? If you have any doubts, let's clear them right now. This instantaneous ID says that machine is in Q1 state and the symbol under head is 0. So we will go for Q1 0. Q1 0, by chance the same, right? So 0 R Q1 means this 0 will be replaced with 0, right? And state will be again 1, and after that your head will move to right. On the right is B, so it will go on. So 0 0 q1 B. Is that clear? Let's see one more step. What next? This time there is a little change. Q1 state and the head symbol under head is B. So we will go for Q1 B combination. This. So for this you have 1 L Q2. So the state at present the scene is 0 0 B this. So Q1B, 1L Q2, this is the move we are to go to. So what will happen? Symbol under the tape head will be replaced by 1. So it will be replaced by 1. And after that state will change to Q2. So instead of Q1 it will be Q2, and the movement of head will be on the left, so it will move to left. Okay, so now what ID becomes 0. Again I repeat how to write the ID. 0 will be written, then you write the state Q2, then the symbol under head, then the symbol on the right hand side. So this is the ID at the moment. Now this goes on, this will go on, transitions will take on, and in the last there will be a situation where there will be no entry into the no entry for the given combination. For example, the machine is in Q3 state and the tape symbol is B, or the machine is in Q5 state and the tape symbol is 0. Q5 tape symbol 0, no entry at here. So this is the moment there where your machine halts. And after this halt of this machine, the state where the machine halts, if that state belongs to the set of final state, is one among the final state, we say that this string is accepted by the machine. So acceptance of a string by a machine M is defined by this terminology. So W is accepted by M if and only if the first initial ID, not first, the initial ID is Q0 initial state, and then we feed W to it, and a transition takes place. After so many transitions, I put a star as usual. This star means multi-step transitions. After these multiple transitions, it reaches to some ID in which some string is on the left hand side and some string is on the right hand side, but the state it switched to is P, and P belongs to capital F. Then we say that W string is accepted by this machine. This means that you initially start at initial state and you feed the whole of the string which is on the right of the head. So after transitions, the status of string may be any, but the machine on halting is at state P, and this state P is one among the final states. So such a string W will be accepted by it if the machine halts at a state which is not final, which is non-final. So that string will not be accepted by the machine at all. I advise all the students to read this topic from your books thoroughly and then prepare notes.